All right. So we already talked about a theorem I didn't think was too terribly useful, but this one I actually like. I actually think this one's kind of interesting and is insightful when you're dealing with polynomials, and that's Descartes' rule of signs. It's also a really easy theorem, but I wanted to explain how it works a little bit before I actually show you the theorem itself. So what I've done, I've written this series of polynomials here, and I want to show you kind of how they behave. So this one right here, obviously this guy's linear. Now all of these guys, the constant is 7. The y-intercept is going to be 7. So this guy is going to start off positive. Okay, it's going to start off at positive 7. Well, what happens as we move to the right here, as x gets bigger? Well, as x gets bigger, we're just going to go up. Okay, we started positive and we went up. Okay, well, what about this guy? This guy starts at positive 7 and then we move down. Okay, as x gets bigger, we move down. Now let's look at this guy. Now, something you need to understand about polynomials is they kind of take turns taking over, because 5x for a while will actually be bigger than x squared. And for a while, 7 is going to be bigger than 5x. Okay? So 7 at first is the big dog, and then 5x becomes kind of the driving force. And then by the end, x squared is going to kind of take over, which we learned about when we talked about end behavior. So if you look at this guy starts positive. This 5x is going to take it more positive, and this x squared is going to make it even more positive. So it starts positive, and then it just takes off. It never goes down at all. But let's look at this guy. This is where things get more interesting. So this guy starts positive. The 5x starts taking it a little more positive, and then our x squared takes over, and our x squared is negative. So what's going to happen to our polynomial is it's going to change direction. Okay, so the switch from positive to negative forced us to change directions. Now let's look here. This guy was positive, starts at positive 7, but for a while this guy is bigger than this guy, so it's going to start to drag us down. It's going to drag us it's going to drag us towards the negative values. But then eventually this guy is positive and he takes over. So we change directions there. Well, what about this last guy? So this guy starts positive. This negative 5x takes us down. And then this negative x squared keeps us going down. So who cares? What's going on here? Well, look at all of these ones that change direction. Well, if we've changed directions, that should mean that the sign has changed. Okay, since the sign goes from positive to negative, that means, okay, now we're changing direction. And here, we started positive, and when we change directions, instead of going positive, now we're going negative. And now we're going positive again. Now, here's why this matters, okay? Why these changing signs telling us about the change of direction, why this matters. So look here. Let's say this is our x-axis. Okay? How many times is this going to cross the x-axis if it starts positive and goes more positive? 0 times. We know it's never going to cross. 7 minus 5x. Again, let me draw my x-axis. I know it's below here because it's a positive value. So how many times is this going to cross? 1 time. The same as my number of sign changes. Well, what about this guy? Well, again, here's my x-axis. And this guy keeps going positive because it just was all positive. How many times is this going to cross the x-axis? 0 times. that's the same as my, that's the same as my number of sign changes. It's 0 times. Here, we started positive, we went up, and then we went down the rest of the time. So how many times is this going to cross? 1 time, which is the same as the number of times the sign changed. What about this guy? This one's a little more interesting because it depends on when this guy turns around. So if my x-axis is here, it went down under the x-axis and went back up. So that would be 1, 2 solutions there. But if it winds up turning around before this, then it's going to be 0 solutions because it turned around before we hit here. So it could be 2 solutions or it could be 0 solutions. Let's look at this guy. Started positive, goes under, keeps going down, hits 1 time. That's because the sign changed 1 time. So now that we've kind of explored why this happens, let's explain what Descartes' rule of sign says. It says if you have a polynomial, and for now we're going to focus on positive real solutions, the number of positive real solutions we can figure out by the number of sign changes. So here I've got a positive. Let me change colors. Got a positive and a positive. How many times did the sign change? 0 times. So we're going to have 0 real solutions, positive real solutions, excuse me. Here I have a positive and a negative. We switched from positive to negative. That's 1 sign change. Okay. Here we have positive, positive, positive. No sign changes whatsoever. We have 0. We have 0 positive real roots. Here I've got positive, positive, negative. I have 1 sign change. So this would be 1 real root, real positive root. Here I have positive, negative, positive. The sign changes once, the sign changes a second time. It could be 2, but it could also be 0. Now, we've kind of shown you visually why this happens. It kind of depends whether it goes below or whether it doesn't, whether it winds up being 2 or 0. Also, we haven't talked about this, but complex solutions come in pairs. So if we have 1 complex solution, we're going to have a second. So that's another reason why this winds up coming in pairs. So this winds up being positive, negative, negative. That's 1 sign change. The sign doesn't change here. So 1 sign change leads to 1 solution. So what we do is we count the number of sign changes. If we have 0 sign changes, that's going to be 0 solutions if it's positive solutions. If it's 1, then it's 1. If it's 2, then it could be 2 or 0. If it's 3, it could be 3 or 1. Okay, because it counts down by 2. You can have these pairs of complex solutions. So if it were 4, we can have 4 or 2 or 0. Okay, let's take a look at a more complicated one. So f of x equals x to the 5th minus 4x to the 4th minus 3x to the 3rd plus 7x squared plus 5. All right. You'll notice I don't have the linear term there. So let's see. This guy is positive. This guy's negative, negative, positive, positive. So what we're doing is we're looking for the number of sign changes. Okay, so one change here, no change. Second change here, no change. So how many positive real zeros are there going to be? Either 2, or remember, we can count down by 2, so it could also be 0. Now, everything I've talked about up till now deals with positive solutions. Well, what about negative solutions? Well, what happens when you go negative is when you take an even power and when you take a negative number to an even power, what happens? Well, that negative just kind of disappears. Well, what about taking it to an odd power? Well, when you take a negative to an odd power, it gives you a negative result. So when we start going this way, okay, when we start going to the left, x getting smaller, these guys are going to have the same effect that they had going forwards. As x gets smaller, this term is going to get bigger because of this positive. This term right here, as x gets more negative, this is going to still go negative. But as we go negative, instead of this guy getting bigger, this guy is going to now be getting smaller. This guy was getting smaller, but if we flip the sign going the other way, this guy's going to get bigger. So basically, any term where the sign changes when you go negative, we're going to change the sign on. So instead of plus, minus, minus, plus, plus, we're going to change the sign on all of these odd powers. So this sign needs to change. This sign stays the same because it's an even power. Change, stays the same, stays the same. So the only 2 that we wound up changing were these odd powers of x. Well, what do we wind up here with here? We wind up with 1 sign change. So on your homework assignment, when it says, hey, how many of these roots are there? Well, you'd say, well, there's 2 positive roots or 0. And there's 1 negative root. So we use the regular rule of signs to get our positive ones, but we change the signs of these odd guys to figure out our negative roots. Let's try another example. Do another quintic one. 7x plus 8. Okay. So let's find our positive roots. So positive, 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 positive. All positive guys. So how many times does the sign change? Doesn't change. So 0. So we have 0 positive roots. Okay. But my odd guy and my other odd guy, we need to change those signs. Change of sign. No change. Change of sign. Change of sign. So there could be 3 negative solutions, but there could also be 1. So that's Descartes' rule of signs. I like Descartes' rule of signs better than the one we were talking about earlier because this one's going to work for any polynomial, and it gives you a really big gut feel for how many times is this thing changing direction, and kind of where are my roots going to be before you've even graphed this thing. So There you have it.